So as we take a peek here at some of the similar problems to yesterday, again, we want to pay attention to the instructions to make sure that we're actually doing the right thing here. So here, we're solving the equation. Round our answers. Woo, the nearest 10,000. Hello. So again, if we're talking about 10,000s, tenths, hundredths, thousands, 10,000s, we're going to 4 decimal places. So that definitely seems calculator worthy here. The other thing I'll make note of is we're wanting to pay attention to our bases of our logs. Okay, make sure they're the same. If they're different, we may have to do something a little bit differently, like we saw yesterday. And then we're just trying to figure out which one of our rules of exponentiating we're going to be tackling. So here on number 1, same base on both sides. That's good news because it means the exponentiating is going to be really easy. Okay, the 16 and the log of base 16 are inverses. Makes them cancel out. And we like it when we get to simple algebra. Because now all I've got to do is move all my p's to one side. So I'm going to minus the 4p over. I like to avoid negative coefficients with my variables. It just makes life so much easier. And then since I'm trying to isolate p, we'll add the 1 over. Nothing too bad, especially when it's a whole number. I don't even have to worry about rounding. So there's a couple more of this type I want to take a peek at. Again, we're going to take a peek as we move down a little bit here to number 5. Now this time I notice something's a little bit different. I've only got a log on this side. I don't on this side. Is that going to change how I do this? Not really. The only time I really got to concern myself with it is if I have an exponent on both sides that's a variable. Then I got to mess around a little bit more. But here, exponentiating with the 6 is still a-okay. On the left, it's my inverse. I just get down to m. On the right, reminder, exponentiate. That negative 1 is an exponent. So I am perfectly fine if you go to do 6 to the negative 1. I'm perfectly fine with 0.166. Now remember, we're going to 4 decimal places this time. 1.66, but the 6 after is going to round that up. So I'm fine with you going to a decimal. I'm also fine, if it works out this way, if you do math, enter, and keep it in a fractional form. They're equivalent. I'm always going to be okay with fractions. Okay? So our decimal worked out quite a ways, or we can work it that way. And so really, as I'm working down here and kind of looking at these, the only thing that I'm noticing as I go a little further is sometimes I may have a little more work to do. Even though I didn't mark 9, we're going to do it. Here, okay, goal, get this log by itself. Can I exponentiate right away, though? Not quite. Because here, I've still got this negative 3 that I'm adding to this. So before I can do my log inverse, I need to go ahead and isolate it where it's more like number 5 was. Once I get that taken care of, now I can go ahead and exponentiate. Okay? Your log has to be by itself before you can do that part. And again, anything to the 0 power, and you can check it on your calculator if you think I'm fibbing, is going to be 1. Okay? But I've got to get that cleaned out first. And it's the same idea on 10, except here, when I'm trying to isolate my v, okay, I'm not adding 10 to it. I don't see a plus or minus in there. I'm multiplying by 10. So when I go to do my opposite, I'm going to divide both sides by 10. Once that log, again, is all by itself on the side, that's the only thing now keeping me away from my v is that log of base 2. Now I can exponentiate. And I go look in here. I'm going to bump this up a little bit so we can get this in. Whoops, not 52. Definitely not 52. 2 to the negative 2%. Thank you. So here, again, I'm fine with 0.25. I'm also fine with the fraction version of it. But again, it's like any equation. We're trying to isolate the variable, and whatever's furthest away, we keep doing it and getting closer until we finally get that variable by itself. Okay? Now, as we flip over, it's going to change up a little bit. Not a ton, but a little. Now, when I get to the back, my situation gets to be a little different. Now I've got multiple logs on one side. Now they're still the same base, which is important. But when this happens, when I see something like this occur, I've got to condense that first. I can only have one log on each side of an equation. So we're going to have to smash these two logs together into one. So we talked a little bit yesterday and reminded ourselves what that looks like. So when we're condensing here, if I have plus, that turns into multiply. And if I would run into a minus, that's going to turn into divide. Well, I notice here I've got a plus. So this is going to become log base 5 x times 6, which is 6x. You could write x6, but... And so I look at this and I go, hey, the next thing in my way towards getting to x is the log. It's the furthest thing out. So we just got done doing that a bunch of times, taking care of that. So I'll use my exponentiating. 5 squared, again, exponentiate, it's an exponent, is 25. And then we'll divide by 6. And again, I'm fine. 4.1667 is okay. 25 over 6, perfectly fine. Being exact, never a problem. And so I kind of work through it that way. So then when we get down to this last piece, everything we've done so far has been log, 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 and I'm doing the inverse. Well, now we're going to change it up a little bit. We're still going to use logs, but now it's going to be our other way of using the inverses. So for instance here, I need to solve for n. This e is in the way. Ooh, we haven't done this yet. What's the inverse of e? ln, natural log. So I take the natural log of each side. N is going to be the natural log of 77. I don't leave it that way. And again, when we're looking for natural log, let's see if I can squeeze this way up here. There it is. Okay, down here next to the 4, so I got the natural log of 77. So 4.343. Then my next digit would be 8. Oh, that's 0. It's not going to change. Okay. And I can get that in. So that's all we're looking at. And then the last one we're going to take a peek at is going to be 22. And similar to what we were doing before, my first job is to say, okay, there's the term that has my variable. Is there anything not connected to it I need to get rid of? Yeah, I need to get rid of this 8. Okay, so what are we doing with that 8? Well, I'm multiplying it. So I got to do the opposite. And yes, you could go to the decimal form of 7/8 at this point if you wanted to. It's not a big deal. But now, it's 3 to the m power. It's not 3 times m. So as I'm doing this, I'm not going to divide by 3. I'm going to take the log of that value. So my left side is pretty straightforward. But the right, remember, it's going to be log of physically big number, 7/8, divided by log of little. So here, I just make sure I close my parentheses on whatever my big is. And again, getting some funky decimal stuff is not bad. And I get my value. I know it's a broken record, but this is a good record. It's a hit record. Okay? If we want things to go well on this unit test that's coming up, you've got to get practice in. Because that review is coming here quick. So practice these. The key is up front. If you need to still look at yesterday's, the book's still open to the right page even. So you can get that set and start working on those. Ask some questions. Tomorrow we start mixing a couple more things back in. And then Thursday we're full blow review the whole unit mode. Okay? Get those set. And we'll try it again tomorrow.